Welcome to Health AI Insights, where we dive into the transformative world of artificial intelligence in healthcare. I'm Lily Body, your guide through this fascinating journey at the intersection of technology and medicine. Imagine a future where AI predicts illness before they strike, where your medical records are instantly accessible and securely stored, and where personalized treatment plans are crafted just for you. That future is happening now, and right here at the University of Texas at Austin, we are on the forefront of this revolution. Each week, we'll bring you in-depth interviews with leading experts, groundbreaking research, and real-world applications of AI in healthcare. Whether you're a tech enthusiast, a healthcare professional, or just curious about the future of medicine, this podcast is your go-to source for all things AI in health. So get ready to be inspired, informed, and amazed. This is Health AI Insights, where the future of healthcare is unfolding today. So today I'm here with Dr. Edison Thomaz. Edison, would you give us a little bit about your background in AI and healthcare?
Yeah, sure. So I am an associate professor here in electrical computer engineering, and I've been at UT for about 8 years now as a professor here. And even though I'm in electrical and computer engineering, my background is actually in computer science. And so I was formally trained as a computer scientist, but because of my experience in engineering and electronics, I ended up in this department. It's a good fit for me, especially because I'm also very interested in hardware. In terms of my background in AI and healthcare, well, I've been interested in the space of machine learning, right? So AI is a term that has been used for many, many years, but has become more popularized recently. And so academically, we've been talking about machine learning for quite some time, especially since the 2000s and then moving forward. And so I was just very interested in thinking about how we could use machine learning for the space of ubiquitous computing and human-computer interaction to learn more about people. How can we make systems that actually can recognize what people are doing, what their needs are, systems that can anticipate people's needs. And as I got more and more into this space, I became very interested in thinking about how this could be used in the context of healthcare. And so that's basically sort of how I ended up working more in this space.
So your research often involves wearable technology. How do you envision the future of wearable devices in healthcare, particularly with AI integration?
Wow, that's a big topic. We'll probably need a lot of time to go over all the possibilities here. But obviously, wearable devices have become more and more powerful. Sensors have become smaller. More recently, we've been talking about not just wearable devices, but ingestible devices as well. Obviously, also with smartwatches and different kinds of fitness devices, activity trackers, these are devices that now we carry with us continuously. They are becoming more powerful in terms of being able to sense the body non-invasively, being able to detect, some research happening about how we can use these devices to detect things like glucose levels, right? And so it's just going to accelerate. We're making more and more progress in this area. I see how in the future there is going to be more intelligent devices that are going to be able to be more proactive in terms of even delivering drugs inside the body, leveraging, onboard knowledge of when you might need to have that drug delivered to you. So it's going to be increasingly more, they're becoming increasingly more powerful, more sophisticated. And we'll see. I mean, I think that they are being adopted more and more by individuals and also by the pharmaceutical industry. So it's an exciting space.
Yes. So why did you pick a ring? Like, what led you to your current research? Why did you think a wearable ring was the route to go, other than other wearable technologies?
Yeah, so the story behind the ring is that I've been interested in the space of dietary monitoring for quite some time, right? So how can we build a device that can keep track of eating behaviors? This is something that has been very hard to do. And there are lots of reasons for why this is useful. I can go into all the reasons, but that will take some time. But one of the things that we've looked at in the past was, can we detect, for example, food intake gestures, like the movement that you make when you're bringing something to your mouth? And the motion is with your arm and your wrist, and you usually have a device on your arm and your wrist, which is a smartwatch. And so we looked at how we could use a smartwatch for that. And we got some pretty good results, but as it turns out, there's a lot more flexibility, or if you will, degrees of freedom in terms of what you do with your fingers when you're eating, because you're holding foods, you're holding utensils. Depending on how you move your utensils, there's some very specific poses that are characterize the eating behavior. And so we decided to think about how we could detect those kinds of motions, not just from the wrist, but also from the hand and from the fingers. And so we can definitely think about how we can do that with a ring. And so we are now thinking about how we can build very small, devices such as rings in the form factor of, devices like these that can actually have lots of sensors and battery and so on, that can actually detect these finger movements.
Yes. So how will your ring differentiate between like some hand gesture that you're doing versus like actually eating?
Well, that's where the whole, AI piece and machine learning comes into play, right? We are going to try to detect specific patterns that are observed only in the context of eating. And this is, an empirical question. We don't know if this is going to be successful. We don't know if this is going to work, but we believe that there are some specific gestures that you only observe when someone is eating something, when you're holding food, when they're, holding, chopsticks or utensils or fork and knife and so on. And so that's the hypothesis. That's the work that we're going to do. We need the device to test it out, and so that's what we're working on. But we don't know. It's still something that we're testing it out, and we're going to be testing this out across different populations, right? So the way in which maybe a teenager eats is different from the way a senior adult eats, and so there's a lot of variation. We believe that these patterns are going to be somewhat personalized, and so we'll see how this goes.
So what are the biggest challenges in collecting and processing this data?
Biggest challenges in collecting and processing this data. So it's not actually a whole lot of data, right? Compared to, this whole world of big data that we live in, it's actually not that much. The challenge is that the data tends to be noisy because as you pointed out, when you have a ring and it's capturing all of your movements, there are a lot of movements that are not going to be specific to eating in this case, right? And so it's really kind of, finding a needle in a haystack. You are moving your arms, moving your hands continuously throughout the day. And only in those, I don't know, 10, 15 minutes that you're having a meal, those are the movements that are specific to eating. And not to mention snacking. Snacking is also very hard. And that's where a lot of times the value in detecting comes into play, right? A lot of people want to avoid snacking, calorie-rich foods and so on. And so that's when it gets tricky because those are movements that are very fast. And so being able to look at windows of time of 10, 15 seconds and say, oh, I detected a particular gesture that looks like it's a food intake out of these hours and hours and hours of movements of your hand and fingers. Is particularly hard. And so that's the challenge, is being able to find that needle in the haystack.
So now this kind of brings up some privacy and ethical challenges. If you can detect just by finger gestures what somebody's eating, what's to say like by what somebody's walking or whatnot. So how are y'all going to address these ethical challenges in your research? And what does this mean for consumers of this product?
Right. Yeah, no, this is a great question. It's a question that is important to be answered. We've done some work on the privacy side of this. Obviously, when you work on systems that use sensor data to recognize people's activities, this question often comes up. And so I always hear about it. And in our research, we've done some work in which we say, obviously, if we don't do anything about privacy, that's a problem. If we are extremely protective, then there might not that many things that we can actually do because we don't have enough access to the data, right? But there's a very interesting spot that's kind of in between here, in which we say, all right, we can maybe intentionally degrade the data such that it provides some privacy protections, while at the same time, we can still have a good idea of the kinds of activities and the kinds of behaviors that are going on. And the challenge then is to find, the optimal balance between having data that is protective, but that still provides enough resolution to allow you to say interesting things about the individual or whatever it is that you're trying to do. And so we've done some work that is essentially about this optimization with regards to video, with regards to audio. And what we do is, as I said, we intentionally degrade the quality of the audio or the video, and then we show that to people and we ask them, what do you feel about this? And they come to us and say, okay, I feel more comfortable now. And then we look at the analysis and we say, all right, this is not as good as if we had high resolution audio or high resolution video, but it's also not that bad. Maybe we lose only 10% in accuracy in some measure, right? And so this allows us to try to find more of a balance between how people feel and what's the potential of the technique from a computational perspective.
Do you think that you will be able to apply this data set, which is very novel and new, to other areas not related to eating or consuming foods and other predictive measures?
Yes, I think that there are lots of potential for leveraging data from a device like a ring on your hand. So let's take, for example, the scenario of cognitive impairment, where you might have individuals with various conditions in which you can observe the severity of a disease by their movements, right? So, for example, obviously you have tremor in the case of Parkinson's and so on. And so that's one case in which we could try to build predictive models from this data. Obviously, we do so much with our hands, and I mentioned the scenario with dietary monitoring, but we can detect other kinds of scenarios and just even activities of daily living in general, right? So we can look at, for example, personal hygiene. We can look at are individuals taking care of their dental health, by detecting brushing teeth and so on. There are just a wide variety of applications that you can think of, just in terms of detecting behaviors with a ring.
Yes. So looking forward, what do you think the next steps in your research are?
Well, as I mentioned, one of the things that we're going to be doing is we're going to be recruiting a lot of people, and we're going to be instrumenting these devices, and we're going to be collecting some data and then doing analysis on it to see what we find. So we are at the stage where, we are getting to the fun part of it. We have some prototypes that we've been working on. We're trying to make them smaller, easier to use, more robust. We would like to test these devices and these techniques not only with people in the lab, but also with people out into the real world. So in some ways, it's easier to detect some of these things in a controlled environment. But then, it's almost like you're cheating. It doesn't quite count. You have to test it out in the real world. And so that's when it gets harder. That's when the signal gets noisier. And so we are about to embark on all that, starting, of course, with more controlled studies. But then eventually we're going to go out into the world and see how they work out there.
Well, thank you so much for meeting with me today, Dr. Thomaz. I really appreciate it.
Yes, it was fun. Thanks for having me.
Thanks for tuning in to Health AI Insights. We hope you found today's episode enlightening. Stay connected with us for more deep dives into the world of AI and healthcare. Also, make sure to check out the UT Austin AI Health Lab, which also I will link below. Don't forget to subscribe, rate, and review us on your favorite podcast platform. Until next time, keep exploring the future of health and technology.